we use in our everyday lives. We use torque from unscrewing wine corks, to opening soda bottles, to using torque wrenches on our wheels. But what exactly is torque? In mechanics and materials, torque is the result of at least one external force twisting a segment of an object. Take a corkscrew, for example. The external force is the hand acting at the top of the corkscrew. The result is torque, which in this case is the screw twisting into the cork. What is the difference between torque and torsion? Torque is a measurable concept, whereas torsion is a concept which is mathematically projected by shear stress or the angle of twist. Torque requires at least one force, and torsion requires at least two forces to occur. Torque depends only on the magnitude, directions, and the separation of forces applied, while torsion depends on the torque, the type of material, and the shape of the object. Torsion is found by using this equation, where tau is the maximum shear stress in the shaft, T is the resultant internal torque at the cross-section, C is the radius of the shaft, and J is the polar moment of inertia at the cross-section. For a solid shaft, J is equal to pi over 2 times the radius to the 4th power. For a tubular shaft, J is equal to pi over 2 times the difference between the outer radius to the 4th power and the inner radius to the 4th power. A helpful technique for solving problems is the right-hand rule. The right-hand rule can be performed by taking your right hand and pointing your fingers in the direction of one axis, then curling them in the direction of another. The resulting direction your thumb is pointing will be the positive axis for the third direction. Another application would be to point and curl your fingers in the direction of a rotation, with the direction of the thumb again pointing in the positive axis one is trying to determine. Angle of twist is the amount of rotation that may occur when the shaft is subjected to torque. This equation is used to find the angle of twist with one or more torques, where phi is the angle of twist of the shaft, T is the internal torque at the cross-section, L is the length of the shaft, J is the polar moment of inertia, and G is the modulus of rigidity for the material. In a transmission, a circular shaft transmits mechanical power from one device to another. Power transmission is expressed using this formula, where P represents power, T is an applied torque on the shaft, and omega is the shaft's angular velocity. Omega is also equal to 2 pi times the frequency of a shaft's rotation. We hope you have enjoyed this video and hope it will help you in the future. Thank you for watching.